Welcome to Ask and Learn.
So we have a refrigerator. First, let us make a layout of a refrigerator. Refrigerator takes out heat QC from a cold reservoir and throws away heat QH into hot reservoir like in our room. And for that we have to supply some mechanical work, W. We supply this mechanical work like through electrical energy, like plugging in the refrigerator, right? Now the question says that these two reservoirs are at 270 Kelvin and 320 Kelvin. The colder one is at 270, that is inside the refrigerator, and the hot reservoir that is outside the refrigerator is at 320 Kelvin. Now the question says, if in each cycle the refrigerator receives 415 joule of heat energy from the reservoir at 270 Kelvin. So it says that QC is equal to 415 joule. So we have to find out how much heat energy it delivers to the reservoir at 320 Kelvin. So what is QH? So we can simply use the ratio of QH and QC to be equal to the ratio of hot reservoir to cold reservoir, which gives us, these are all in magnitudes, okay, so that you don't need to worry about signs. So if you substitute the value of QC, TC and TH, you're gonna get QH to be equal to 491.85 joules. So this much amount of heat is what the refrigerator throws away into our room, or the hot reservoir, right? Now the second part of the question asks us if the refrigerator completes 165 cycles each minute. So in 1 minute it completes 165 cycles. So how much power input is required? Okay, so power input is required. So power input required is based on how much work that we have to do in this refrigerator. How much work we have to do in this refrigerator determines how much power we need. So in 1 minute, how much work needs to be done? So 1 minute has 165 cycles, right? So in one cycle it does W amount of work. So in 165 cycles it does 165 into W amount of work. So what is W here? Amount of work. W is obviously QH is the sum of QC and W. So W is QH minus QC. So if you substitute the value of QH and QC, we get this to be 12,680.25 joules. So in 1 minute we have to provide 12680.25 joules of mechanical work, which means that in 1 second, just divide this term by 60, you will get 211.33 joules of heat energy that is to be given, right? So the mechanical work done per second is actually power. So this gives us the power input that is needed. So power is equal to simply 211.33 watt. So this much power input needs to be given. So the next part of the question asks us, what is the coefficient of performance? So let me do this in this small space here. So coefficient of performance K is equal to how much heat the refrigerator was able to take out from the cold body and how much work did we have to do for the refrigerator to work. So this is equal to 415 divided by again the difference between QH and QC. Now as you substitute the value of QH and QC in here and calculate this, you get K to be 5.4. Well, the performance coefficient of performance for this refrigerator is 5.4. So this concludes the solution for this question. Thank you for watching.